was able to assist you somewhat, and so that we can be able to obviously touch on that. So let's move on to that. We asked the question last week that you name the two type of sex cells that are found or that are important for human reproduction. The answers for that are the egg and the sperm cell. So that would be one answer for each of those. You realize that on the right-hand side of the screen of this PowerPoint presentation, we have put numbers that are inside parentheses so that those are giving you an idea of how many marks each question was worth. So question number one, it's the egg and the sperm cell. So you can think about, did you answer that correctly? If you did not, of course, this serves the purpose of you further understanding that further. Question number two, we asked what fertilization is. And you'll remember that I said, let's ask that question in a way that is asking you to answer on the basis of how you understand fertilization. So basically, we wanted you to be the person that uses your own weight, your own understanding to respond to what fertilization is. But fertilization, ladies and gentlemen, is the fusion or the combination of the egg as well as the sperm cell. So basically, that is what fertilization is. On question number three, we asked you to say, what is the relationship that exists or that is found between the embryo as well as the fetus? Now, in that being said, ladies and gentlemen, the first thing is to obviously look at the mark allocation. So the mark allocation there was 3 marks. So obviously it means in your response, you need to be responding to a point where you get the 3 marks in terms of how they are. Now, the first thing to do in that question is to first explain or define both the embryo as well as the fetus, and then you find a connection between the two, hence the word relationship. So the first part of that is to say the embryo is a fertilized egg. Remember, we said fertilization is the combination of the egg and the sperm cell. So basically, that is what an embryo is. Now, ladies and gentlemen, that happens immediately when the egg cell has been released into the uterus, and then the egg cell has been released into the uterus during what we call ovulation, which happens when a female goes through that once a month. Now, the egg will then stay there in the uterus and await for fertilization to happen. Now, then there will be a sperm cell that will then come and fertilize that egg. Then immediately when that has happened, that becomes an embryo. But after a period of 3 months, that embryo develops into what we call a fetus. So again, what is a fetus, ladies and gentlemen? A fetus is an embryo that has been developed. So basically, that's how we respond to that question. We define the embryo, we define the fetus, then we find the connection or the relationship. That is the fact that the embryo is the development of the fetus. That's how we respond to that. Now, we then go to question number 4. We then asked you to suggest or recommend 2 items that can be used by females when they go through menstruation, what we normally call the period. Now, these are known by most of us, but that question is important, ladies and gentlemen, because it speaks to hygiene, it speaks to sanitation, and all of those things that we learn in life skills. Now, the answer for that would be the pads as well as the tampons. So that's the simple answer to that. Question number 5, ladies and gentlemen, we asked you to say, what would you suggest that would then avoid STIs as well as pregnancy? For people, as I had emphasized on the previous lesson, that feel that they are mature and old enough to then be able to involve themselves in sexual activity. As I've stated before, for this grade 7 level, for our level, ours is to learn the theoretical part, ladies and gentlemen. We are not at that level of maturity to be engaging in such. But that does not mean that we cannot then assist the people that are engaging. So we then said that there are 2 ways in which would suggest that people do that. The first one, ladies and gentlemen, is through abstinence, which is what we are all doing at grade 7 level. We are abstaining. What does that mean? We are not engaging in sexual activity. The second part for people that are engaging is the use of what we call a condom. Now, that's the second part. Again, ladies and gentlemen, you will see that there's a mark for each and every response that we have all got in there. Now, it is my hope and it is my wish that we got that correct in terms of understanding what it is that we are doing, so that we can be able to test ourselves, so that we can be able to know what is going on. Forgive me, let me just open the screen again. I just want to move to today's lesson objectives. So that was term 1 that we focused on. But now we need to move into term 2 because that's where we are. As we know that schools should have been opened already, but because of the pandemic, they are not. So it means that the show needs to continue moving. Now, the first topic or the first lesson that we're going to have in term 1 is what we call matter and materials. Now, what are the lesson objectives that we are going to actually speak about here? Number 1, we are going to define what matter is. Number 2, we are going to explain and or define what material or materials are. Number 3, we are going to explore the physical properties of materials. So those are our lesson objectives. That's what we need to have learned when the lesson ends. Number 1, the explanation and the definition of matter. Number 2, we need to explore what it is that we mean by material. Number 3, what are the physical properties of the materials that we are going to actually look at? So those are the 3 objectives that we want to achieve by the end of this lesson. Moving into the next slide, ladies and gentlemen, it needs to be noted that this topic that we are covering is a topic that was done or is done currently in grade 4, 5, as well as 6. So that's why I'm saying these are questions that we need to think about so that we can understand where it is that we are standing in terms of our understanding for the level that we are at. To say in grade 6, do we remember when they said what is matter? Because that was done there. We also need to understand what do we understand by the word. And then the last question, also that is tying into the objectives of the lesson, give any 3 physical properties of materials that you know. Now, ladies and gentlemen, all around you as you look, I'll give you a hint. We are seeing various materials. We are seeing various meta elements as we are speaking right now. And we're going to explore the validity and the truth of that statement as we go into the lesson. Going into the lesson, ladies and gentlemen, the first thing that I want us to explain is that matter is everything that is found around us. It's everything that has got mass, and by mass we mean weight, and it's everything that takes up space. Meaning that whatever it is that we are speaking about has got a certain amount of weight, heaviness, how heavy or how light. And over and above that, it takes up a certain space. So when you put it there, you can see that it's there. So it has taken up space. So mass is everything, ladies and gentlemen. And I've given a couple of examples there. The first one is brick or bricks. The second one is the laptop that you are actually probably using for the purposes of the streaming of this lesson, or the cell phone that you're holding in your hand, and probably the food item that you had prior to this lesson, or in the morning or after we finish that lesson. So basically matter is everything, ladies and gentlemen. But obviously, because this is natural sciences, we are going to explore what it is that we mean by that. The second part of the objective of this lesson is to explain or define what a material is. And we are saying a material is anything that is made up of a substance. That is a material. Now, it becomes sometimes confusing to say matter and material. What is the distinction? There is not much distinction, ladies and gentlemen, except that they actually work well together in terms of how they work and what they are. So remember, I gave you an example of a brick. And I said to you, a brick is an example of matter. Now, I want us to explore that. You'll see that I've put certain words in certain different colors. I've done that because I want us to look at those and focus solely on those ones. Number 1, we are saying soil is a substance, right? We are saying that's what soil is. But then that substance that is soil assists us so that it can be able to
Hello, Alex.
Hello again.
Yes, can you hear me?
I think we are back.
Awesome.
Yes,
okay,
I can hear
awesome.
you. I believe we are back.
You can continue.
All right, thank you so much. I can see Butimelo there and Busani. Hello, how are you guys doing? Thank you so much for joining us. I understand and I know that there's other people that are out there, but on my screen, I can see Butimelo as well as Busani. Thank you so much. Ladies and gentlemen, let me apologize for that interruptance. I want us to then revise what we actually were doing before this happened. Now, we said the objectives of this lesson is that by the end, we should have understood what matter is, as well as what material is. So the first thing that I'm going to do is speak about what matter is. Now, matter is everything that is around us that takes up space. What does that mean? When you put it there, you can see it has taken a certain amount of space, and also it has got mass or weight. What does it mean? It means it's got a certain element of heaviness or a certain element of lightness. So that's what it is. So everything from the bricks that assist us to make the houses, from the laptop or the device or the phone that you're using as we are speaking and having this lesson, and the food item that you ate before this lesson and you're going to eat after this lesson. So everything in the world, ladies and gentlemen, is matter. Now, that's the first part. The second part is, what is a material? Now, a material is anything that then makes up matter. So you have a material that then assists us in making what? In making matter. In the previous explanation of matter, I said a brick is an example of matter. I want to use that example to explain what it is that we mean when we say a brick is an example of a substance, and or a brick is an example of matter that is made up of what? A substance. Now, what is it that makes bricks, ladies and gentlemen? It's soil. So a soil is a substance, right? So you've got different types of soils, of course, your loomies, your sandy. We're not going to get into the elements or the details of that. But soil in its natural form is a substance. We then as human beings use soil to make matter. What is the matter that we make? Is a brick. So again, let's revise that. Matter is anything in the world that has got mass, which is weight, and that takes up what? Space. It's anything that we can hold, anything that we can taste, anything that we can feel, anything. Hence, I made an example and I said the laptop that you're holding or the device is an example of what? Matter. Because it takes up space. As you're holding it in your hand, it has taken up space, number one. Number two, it's got a certain level of weight, meaning it's quite heavy or it's quite light. So therefore, it's an example of what again? Matter. Now, when we speak about a material, what are we talking about? We are speaking about anything that makes what? That makes matter. Any substance that then will be able to make matter. And I said, from the example of the brick, that is matter. It's made up of material. What is that material or substance? That is the soil. So basically, that is that, ladies and gentlemen. Let's move on into the next slide. In the next slide, ladies and gentlemen, we want to speak about the physical properties of substances. And when we speak about the physical properties of substances, we are speaking about how does a substance actually react or behave, or how is a substance. So basically, what is the nature of that substance? Now, if you are holding a laptop, the most easiest example of understanding a physical property is the color of that substance. The laptop that I'm using, ladies and gentlemen, is black. So the color black is the physical property of the laptop holding. If you're holding a phone and it happens to be silver, so the physical property, in terms of the basic understanding of what a physical property is, that phone's physical property is silver, because that's how that phone is. However, that's just one way of looking at all of those things. I see that Charles Chauke has joined us as well. Welcome, Charles. Let's continue. So we've got certain examples of physical properties. The first example that I want us to explore is the strength. The strength, ladies and gentlemen, has nothing else to do than how strong a material or a substance is. So that's it. How strong is it? Is it breakable? Can you break it? Can you bend it? So that is the strength of how strong it is. Tess Naidu has also joined us. Welcome, Tess. So basically, the strength speaks to how strong that material is. And I've put an example there. If you check the picture that I've put there, the picture that I've put there is a picture of a steel bar. Now, in grade 7, ladies and gentlemen, in technology, we speak about a bar when we are talking about a lever. But obviously, this is not technology. This is natural sciences. I'm just using that as a way of integration and a way of understanding what it is that we're talking about. Now, if you think about the steel bar that I've put there, those are usually found in the window frames that we have in our houses. Now, how difficult is that to break, ladies and gentlemen? Very difficult. Now, because of the difficulty of breaking that, it means the physical property of the steel has got an element of what? Of strength, because it is strong and it's not easily breakable. So that's the first physical property. The second one, ladies and gentlemen, is flexibility. What do we mean by flexibility? Obviously, flexibility, ladies and gentlemen, speaks about the ability of a material to stretch without breaking or being damaged. Now, obviously, there's a lot of examples that we're already thinking about. We are obviously thinking about elastic bands. There's a lot of these that we also find in our clothing items, and therefore we can be able to wear them and stretch them as much as we want. Our jeans, ladies and gentlemen, are also great examples of that. But an example that I've put there is a flexible plastic ruler. You know that flexible plastic ruler that you can roll as much as you want, stretch it as much as you want, and when you do that, there's no breaking in that ruler. Why is that? Because it's got a physical property, which is called what? Flexibility. Now, the third physical property I want us to speak about, ladies and gentlemen, is the boiling point. What do we mean by boiling point? Obviously, immediately when we speak about boiling, what should be coming to our heads is that it means there is an addition of heat that therefore enables whatever item. In a lot of instances, that item is a liquid. Ladies and gentlemen, you realize that when we speak about boiling and melting points, we are then talking about the physical states of matter. In grade 6, we learned that physical states of matter speaks about the solidity of an item. They speak about the gaseousness, that is the vapor or the air. They also speak about the liquid element, and that is water in its form. And obviously, when we speak about property, we start saying, if you look at the solids particles are all clustered together because a solid is one thing. Like my cell phone is an example of a solid item because it's solid, it's strong, I can hold it in one item. When we speak about a gas, ladies and gentlemen, we speak about something that is obviously gaseous in how it acts or reacts. When you add heat, there's a vapor that has been released. Now you will see that in the picture there of the boiling point, there is vapor that is coming out of that beaker wherein there's the water that is being boiled. And obviously the boiling of water speaks about the increase in temperature, right? So that is a gas. So the vapor that is released or the gas that is there. When we speak about the third physical state, we are talking about water, which I actually have. Remember last week I had said that I was quite thirsty in between our lessons. So this would be the water that I'll drink now. Please excuse me. So that is water. And when we speak about the particles of water, we are told that the particles of water flow. So as you pour water in a certain surface, there will be a flow that is happening. So the water would move from one point to another. However, in the flow that they have, water has also got an element of taking the shape of whatever container it's put in. So if I, like I have done, have put water here, and I take this water that I've put here, I put it in the freezer. What's going to happen is that the liquid that is here, as you can hear, that's the sound of liquid. The water is flowing in this bottle. Now, this liquid will then do what? It will take the shape of this water bottle. So as you can see, this is a very quite shapy bottle. So it will take this shape. And then when it takes that shape, it will then become a what? A solid. If we take that solid ice of water that would have frozen, so meaning we've decreased the heat, and we put it in the boiling element, and we increase heat as we've done there, what happens? That water then starts to boil and therefore changes shape. Then there will be a vapor that will be released. So boiling point, ladies and gentlemen, is the temperature, and that temperature is changing the liquid, which is water, to a gas. How does that happen? The boiling point is at 100 degrees Celsius. Again, let's note the words that are underlined there. That's very important. So we can see that the measure of measuring temperature is degree. And obviously water starts to boil at 100 degrees Celsius, changing water, which is a liquid, into a gas. All right, ladies and gentlemen, now we then move into what we say, the melting. So what is the melting point of the physical property of materials? So as you can see in the picture there, put ice blocks, and those ice blocks, when you introduce them, or rather when you leave them in a situation where there is a lot of heat, those ice blocks start to melt. They then melt, meaning then those ice blocks change from a solid, which is the ice block, into the liquid, which is the watery. type of a form of water that we can see there. So we can see the ice blocks, and around the ice blocks, you can see that there's water, and that water is liquid. So then that's the water that's the ice blocks that then is starting to do what? To melt. The fourth physical property, ladies and gentlemen, is what we call electrical conductivity. Now remember, when we did electricity in the third term, in natural sciences, that's grade 4, 5, 6, as well as grade 7, we are still going to do electricity. In electricity, we speak about conductors, and conductors are materials that are good for moving electrical current from one space to another. And the greatest examples of conductors are copper wires that we find when in our chargers, when we charge our phones, or in the cable extensions for our televisions or our kettles. When you cut that, of course, we're not going to do that. We don't want to be fighting with our parents for damaging appliances. But I'm saying inside those copper, inside those wires, you find that there's copper, right? That is then moving the electric current from whatever port you've connected into the actual appliance. So it's conducting the electricity, number one. Number two, the very same wires that I'm speaking about, as I've made an example about copper, they are covered with what we call insulators. Now, what are insulators? Insulators are bad conductors of what? Electricity, such as plastics. So you've got a copper wire that is then used or to connect, or rather to move electricity from the plug all the way to the ion, for an example. Now, in that copper wire, that's how electricity is moving. It's a good conductor of heat. But then what is covering that copper wire to stop dangers of you getting shocked and all of that, and all the hazardous safety rules or elements that we understand and know about electricity, you find a plastic. Now that plastic is an insulator. So what are we saying? We are saying that one of the physical properties in terms of materials is electric conductivity. Now, is that material a good conductor of electricity, or is it not? You will see in an example of the picture that I have there, we've got copper wires that are almost connecting with each other. They are conducted. How are they conducted? There's electric current that we can see almost in the form of fire there. That light that is orangish, that is what we are talking about. Now that is able to do what? To connect the electricity. So that's electrical conductivity. Now those wires are covered by what? If you check again, there are plastics that are covered by those wires. And what do we call those? We call those insulators, because they are bad conductors of electricity, ladies and gentlemen. Moving right along. We then want to also speak about the heat conductivity of materials. What do we mean by that? Remember, heat speaks about the hotness of a material, or of anything that you see. When we charge our phones, at the back of our phones sometimes, depending on how long we charge them, there's a certain amount of heat that we feel. Same thing that applies to our laptops. When we charge them or connect them, we feel. So heat, another way to speak about heat is what we call thermal. So that speaks to what? How hot a substance is. So this is the ability for a material to store heat. If you think about the pots, if mom is going to cook around, what is the time now? The time is 3:30. So mom is cooking at 3:30. Obviously, mom, what has mom done, or dad, whoever is doing the cooking? They've put a stainless steel pot on top of the stove, and they're cooking. And they finish the cooking at what time? Remember I said now it's 3:30. They finish the cooking at like 4 p.m. When the cooking is done at 4 p.m., supper is probably going to be, you're going to eat whatever food has been prepared at 4:30. Now, if you switch off the stove, that pot is going to maintain the heat from 4 p.m. when mom or whoever is cooking, or dad has finished cooking, all the way to 4:30. Now that speaks to electrical conductivity of certain materials. And as I've said, pots are great examples of that. You can see the pot that is there, and that is also boiling the water. If you remove that water, for an example, hypothetically speaking, and you put it on the side, that water is still going to boil until it loses what? The heat. But at the point in which it has not lost the heat, that stainless steel pot has maintained the heat, therefore its heat conductivity. And what you must also realize, with heat conductivity, it's almost always connected to electrical conductivity. Materials that connect electricity are also good heat conductors, ladies and gentlemen. Not all the time, but that's also a very easy way of remembering that. The last physical property I want to speak about is texture. Texture speaks about the feel of something. When you touch something with your hands, how does it feel? You'll see the very nice, interesting pictures I've put there. The smoothness that is smiling. Usually when you hold something that's smooth, there's a certain gentle touch. There's a gentle feeling that you feel because that thing is just rubbed through. So it's very soft and it's very smooth. However, there are certain materials that when we touch, they are rough. For example, sandpaper. Maybe a lot of us don't know what that is, but very rough in how it is. Sandy soil, it's got a very rough type of a feel in terms of how it is as a substance, you know. So what are we saying? We're saying texture is also one of the physical properties of materials. And what is texture? How something feels. Is it smooth? Is it rough? And roughness, obviously, like I say, you can feel a certain amount of discomfort as you touch it. There's a certain amount of discomfort. Smoothness, there's a flawless type of a movement in relation to that. So those are the 6 types of physical properties of elements, right? So now when we move on, we want to also just add another information of physical. These, ladies and gentlemen, in grade 6 were done. The first one is what we call, is a substance malleable or malleability. What does that mean? The ability of a substance to be able to change its shape because of pressure that is applied. When you hammer something, are you able to change its shape? One of the greatest examples of that is gold, right? If you look at mom's ring or dad's ring, if they're married, or if you are into jewelry and you are wearing a necklace or you're wearing any form of jewelry, ladies and gentlemen. Oh, I see Butumelo is back. Welcome back, Butumelo. Hello. Wave. Anyways, let's continue. So that speaks to, are you able to change a certain material? In a lot of instances, I see Butumelo is waving back. In a lot of instances, that material is solid. So as you hammer it or as you press it, then you change the shape. As I've said, gold is a great example. So we change the shape of gold from being a solid, as you can see in the picture there in the center. So if you dig gold, or when people are mining for gold, that is how they find gold, right? As they are hammering the gold, obviously, they introduce a certain level of heat, they start extracting gold from stones, etc. Then they change the shape. So that speaks to malleability. So are you able to change a material's shape using what? Compression pressure. What is compression pressure? When you press something or when you heat something. Now, we also go to another point, which is what we call ductile. What do we mean by a substance that is ductile? We are talking about the ability of a substance to be able to stretch. When you stretch something, ladies and gentlemen, let's not confuse these. This is solely based on what? In a lot of steel materials. Remember, we spoke about stretch earlier on as one of the physical properties, but also now we are introducing something else to say, are substances ductile? So what does it mean? As you can see in the picture there, you've got a copper metal wire. When you stretch that wire, that's ductile. The pulling pressure that is applied, again, you realize that as we are speaking about pulling and pushing, we're also speaking about technology there. And again, I'm saying it's important for us to note that because of integration, when we do technology in grade 7, which is a new subject, we also touch on those. So ductile, when you stretch a metal or when you stretch a material. A malleability, when you press something to form a certain number of sheets, right? So you're pressing it. Aluminium is also a great example of that. And gold, I've spoken about that as well. So those are just 2 additional informations that we think are important, particularly as you go up, of course, into the grade 8s and grade 9s, because you'll also speak about that. So ladies and gentlemen, I also just want us to speak about the following slide. In the following slide, if you can, please, just take a picture of this or a screenshot, because I want us to do this after this lesson so that we can be able to see if we understood everything that was being done. So I've given you a table there. In the table that I've given you, I want you to investigate the physical properties of the materials that are found on the far left of the slide. What are those materials? That's the gate, that's the elastic band, that's the wooden desk, that is a common feature in our classrooms, that's water, which I drank a couple of minutes ago, the plastic chairs. That is also a common feature that is found at school or in a classroom situation. Now, how do I want us to investigate this? You look at gate. You say to yourself, does gate have a certain amount of strength? Remember, we said strength has to do with whether something is easily broken or something is easily bendable. If a gate has got an element or a characteristic of strength. Ladies and gentlemen, you simply tick on the strength or you cross it. If it does not, you leave it as blank. You don't do anything. You go to flexibility, you do the same. A gate, is it flexible? Can you stretch a gate? If you can, ladies and gentlemen, you tick there. We go to boils. Can you boil a gate? If you can, of course, ladies and gentlemen, by all means, you do what? You also tick there. Can you melt a gate? You tick if that is the case. Is gate a good conductor of heat? If the answer is yes, ladies and gentlemen, what do you do again? You tick there. So basically, that's what we are doing. So we are looking at the 5 materials and we are investigating whether the 5 materials, in terms of the physical properties, what is it that they are able to do? Remember, we said physical properties are behaviors of materials. So that's why I'm saying with the gate one, I'll give you an example. A gate is a very good example of strength. So I can already tick across there. Now, is it flexible? That's on to you. Can you boil a gate? Can you melt a gate? Is a gate a good conductor of heat? Ladies and gentlemen, you are going to be doing this at home. Again, like I said, let's take a screenshot of this table or a picture of some sort so that we can be able to do this activity. Then tomorrow when we do the lesson, we can then start by doing corrections in that regard. Remember, as we are answering this, we are going to hashtag, apologies, lockdown is school. So as we are responding there, that's what we are doing. Hashtag lockdown is schools. Moving right along, I want us to look at the taking points of what we've done. That is, what have we understood by this lesson? And remember, I spoke about objectives. So have we achieved this by the end of the current lesson? Number one, the understanding that matter is everything that is around us. So already I can see Butomelo there is watching with mom. Hello, mom. Now, as they're watching through either a device, and I said a device is an example of what? It's an example of what? Of a material. So that is a device. That is a laptop. That is a phone. I see that Lumko is joining us. Welcome, Lumko. How are you, sir? So that's the first thing. So matter is everything that we find around us. The cell phone, the laptop, everything. And we said it's everything that takes up space. So meaning that when you put it somewhere, it has taken a certain amount of space and that it has got also what? Mass or weight. That's the second objective that we wanted to achieve. The second objective is a substance. What is a substance? A substance is something that we use to make what? A material. I said an example of matter is a brick. But a brick is made up of what? A substance. What is the substance? That is soil. So when you take soil and obviously you introduce it to water and other substances, what do? You create a brick. What is a brick? It's matter. So that's what we are saying. So matter is everything. An example of matter in that example is a brick. But a brick cannot just be a brick from the sky. Something makes a brick. What is that? That is soil that we find around us. So that is a substance, something that makes a material or something that makes matter. Then we spoke about the physical properties of materials. We said these are the behaviors of a material or the characteristics. Ladies and gentlemen, maybe we should go back and explore these behaviors. We said the first behavior is strength, how strong something is. Give an example of a steel. We then said that's flexibility, the stretching of a material without being damaged. We then said then we've got what we call a boiling point. Boiling point is the introduction or the addition of heat. So when you put water with water in a pot and then you put it on top of a stove, you're putting heat there. What happens to that water? It starts to boil. So what is happening? The water state is changing from liquid to what? To a gas. So that's changing states of matter. So you had water initially that you got from the tap. You put it in the pot, you put it on top of a stove. Water changes its liquidity to what? To a gaseous form. What is the boiling point of water? It's 100 degrees Celsius. We move again to melting point. What do we mean again by melting point? Again, ladies and gentlemen, remember grade 6, the changing states of matter. So here, a solid is being changed into a liquid. So you've got an ice cube, as you can see in the picture. Now you take the ice cube out of the freezer or the fridge, you put it somewhere, maybe in the sun or in the pavement. What happens to that ice cube? It starts to change from the solid of being ice into what? Into water. We then move to the fourth physical property of materials or matter, and that is electrical conductivity. So that is a material a good conductor of electricity? Can it move current from one place to another? Copper wires are great examples. As you can see there in the picture, we've got a copper wire, and that light that is in between those two groups of wires, that light is electrical current that is being conducted by what? by the copper wires. What is covering those copper wires? It's a plastic. What is a plastic, ladies and gentlemen? It's an insulator. So it's something that breaks electric current, so that when you take a plug of maybe your charger of the laptop, you do not get a shock. And then you obviously suffer the consequences that we don't want to speak about. The fifth physical property, heat conductivity. What do we mean by that? We are talking about the ability of a material to allow heat to pass through and to store it. I made an example. I said, if you cook a meal right now and you stop cooking that meal using a stainless pot, and you put that stainless pot aside, that stainless pot, the contents of that stainless pot, if you're making rice, for an example, that rice will still be hot for a certain period of time. Why? Because that rice has been stored or is inside a stainless steel what? Pot. So a stainless steel pot is a great example of what, ladies and gentlemen? Of heat. And I also said, usually, good conductors of heat are good conductors of electricity, ladies and gentlemen. In a lot of instances, not always. The last physical property we spoke about is texture. That is how smooth or how rough a substance is. Now you can see those two examples. Roughness, certain amount of uncomfortability. Look at the picture rough there. It's almost screaming. It's quite uncomfortable. If you look at the smoothness, the smooth surface, there is a smile. So basically that's us trying to check whether we have obviously succeeded in the objectives of this lesson, ladies and gentlemen. Now moving on, these are helpful links. The first one is a YouTube video that will then introduce matter and materials further. Again, like with the previous one, if you feel you want to take a picture, ladies and gentlemen, definitely do so that you can be able to go onto this video and check out how they also speak about matter and materials. So that's the first one, the YouTube video. The second one is a Siyavula lesson. Interestingly enough, Siyavula is actually a project by Sasol, which is also a sponsor for this project. So it's also important for us to use the resources that are already there at our disposal. So you go on to the Siyavula link, you click on it, ladies and gentlemen. You then also go on to a specific lesson that speaks about the physical properties of what? Of matter. The last one is also a link. It's got a video and also a lesson there and also worksheets, ladies and gentlemen. So like I said, you may take a picture of this, you may record this, or you may screenshot this so that you can also explore those links in your own precious times, of course. Now, what are we doing tomorrow, ladies and gentlemen? Remember we spoke about matter and materials. We then spoke about the physical properties. Now we need to speak about the impact that matter and materials have on the environment. So that's what we are doing tomorrow. We are looking at the impact, the environment, the impact of matter and material have on what? On the environment. How do they impact the world around us? How do they impact the sea, the water, the air, everything, ladies and gentlemen? So that's what we are doing tomorrow. We want you to, of course, follow us on social media. So that is hashtag Lockdown is School. That is at African Teen Geeks. That is at Izora, at DBE_SA, at Sasol Foundation, at Sasol SA, hashtag STEM Champions. Ladies and gentlemen, thank you so much for listening. I will see you guys again tomorrow when we investigate the impact matter and material have on our environment. My name is Alex Songo. I'd like to thank you very, very much, ladies and gentlemen. I will see you guys tomorrow. Thank you and goodbye.